The dwarf planet Ceres, the largest object in the asteroid belt, has been surprising scientists since it was first discovered. Now the latest discovery to come from the dwarf planet shows its surface is not as rich in carbon as observations had previously indicated. It turns out the carbon-rich material on Ceres' surface is just fragments of other asteroids, and it means the dwarf planet is not as similar to asteroids as we thought. Although it was called an asteroid for many years after it was first discovered, Ceres is much larger than the rest of the objects in the asteroid belt and was classified as a dwarf planet in 2006. Researchers thought it had a similar composition to the rest of the asteroids in the belt until now. A new set of infrared scans by NASA's Stratospheric Observatory for Infrared Astronomy shows the surface is likely contaminated by material called dry pyroxene dust from asteroid impacts mixing in with wet dust, ice and carbonates. This challenges the previous classification of Ceres as a carbon-rich body and suggests it may have formed near the edge of the solar system. Models of Ceres based on data collected by NASA's Dawn spacecraft plus ground-based telescopes indicated substantial amounts of water and carbon-bearing minerals such as clays and carbonates, said Pierre from NASA, lead author of the study. Only the mid-infrared observations made using SOFIA were able to show that both silicate and carbonate materials are present on the surface of Ceres. The Stratospheric Observatory for Infrared Astronomy is a joint German-US space science project carrying an 8-foot telescope inside a modified Boeing 747 SP. The airborne observatory performs astronomical observations high above the disturbance of Earth's atmosphere. The study resolves a long-time question about whether asteroid surface material accurately reflects the intrinsic composition of the asteroid. From NASA added, our results show that by extending observations to the mid-infrared, the asteroid's underlying composition remains identifiable despite contamination by as much as 20% of material from elsewhere. SOFIA, with its airborne location and sensitive forecast instrument, is the only observatory currently operating or planned that can make these kind of observations, said Frank Marquez, co-author of the study published in the Astronomical Journal. These and future mid-infrared observations are key to understanding the true nature and history of the asteroids. Material transported from across the solar system can affect the surface of moons and planets, not just dwarf planets and asteroids. The scientists also studied interplanetary dust particles that form meteors when they are seen streaking through Earth's atmosphere to identify where the pyroxene on the surface of Ceres came from.